Hello viewers, Wagada now taking you through the story for A-level pure mathematics, and this video will be on indices, surds and logarithms. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So far, let's first look at the course outline. Like I've already told you, pure mathematics or math paper 1 is divided into 5 parts. The first part is algebra, which has two questions come in section A and 2 in section B, and these are the topics. The next is trigonometry, where one question comes in section A and one in section B, and these are the topics. Then the other part is geometry, where one comes in section A and one in section B, and these are the topics. Then another one is vectors, where one comes in section A and one in section B, and these are the topics. Then the last one is calculus, where 3 questions come in section A and 3 in section B, and these are the topics. So the topics which are ticked are the ones we have covered. So this time we're going to go, this video will be on algebra, and it will cover these 3 topics. So now we shall start with indices. Now an index, indices is a proof word and index is the singular. So an index is the number of times the base is multiplied by itself. So therefore, in general, a to power n means multiplying a by itself n times. This means that if you have 2 to power 5, it is no longer 2 times 5. Most students confuse and they write 2 times 5, and that is not okay. So what does 2 to power 5 mean? 2 to power 5 means you multiply 2. This is the base, so you multiply it by itself. How many times? 5 times. So that is why you see here 1, 2, 3, 4, and 5. So that is what 2 to power 5 means, and basically that is what indices is all about. But for you to go through the questions on indices, you need to know some of the laws of indices. So when numbers with the same base are multiplied or divided, their indices are operated according to certain rules. Let's start with this rule of multiplication. So the rule of multiplication says that an index of a product is the sum of the given indices. Therefore, if I have a to power m times a to power n, I think we realize that the base is the same. It is a. And because there is multiplication here, it implies that you get the sum of the indices. That is why you see a plus. However, if the power is the same for different bases, then it implies that, for example, if it is a, in this case I think we realize that in the previously it was the base which was the same, but there are some cases whereby it is the power which is the same and the bases are different. So in that case, you just multiply these 2 bases to come up with this, then raise the same power. So those are the 2 conditions for multiplication. The base can be the same or the power can be the same. Then the second rule is the rule for division. So the index of a quotient. Now quotient is another word to mean division. So the index of a quotient is the index of the divisor subtracted from the index of the dividend. Now dividend is the one in the numerator and divisor is the one in the denominator. Therefore, the index of the divisor is this n, and the index of the dividend is this m. Therefore, the index of the divisor is subtracted from the index of the dividend. So this n is subtracted from this m. That is the rule for division, as long as the base is the same but the powers are different. So because it's the division, that is why here you see subtraction. However, sometimes it may be that the power is the same but the base are different. What does that mean? It implies that you come and first divide the bases to come up with this, then raise to the same power. Then the third rule is the rule for powers. So rule for powers, you can be given more than one power. As long as more than one power, just know that all those powers will be multiplied. So this time there is this power and there's also this power. All are powers of a. Therefore, it implies that you have to multiply the 2 powers and put them on the same base. So the letter A has been used in the above examples to represent any number. So A can mean 2, 3, -1, or integers. So it can mean an integer, it can mean a whole numbers, it can mean fractions. And same applies to M and N. So those are the rules. Now there are some things we need to know. One is the zero index. These are special cases. Special cases that any number raised to the power 0 will always be equal to 1. The another one is negative indices. Now, this is also a special case. It says that for negative indices, any number raised to a negative index, it is the same as the reciprocal of that very base, but the power becomes positive. I think you realize that if this power is negative and you want to make the power positive, you have to get the reciprocal of this and make it and make the power positive. So the note here is that the laws of indices apply to both positive and negative indices. So these values of M and N, they can either be positive or negative, or one can be positive and another one negative, or the rules will still apply. So with that, let's first go through some of the questions. Question 1 says, without using mathematical tables or calculator, simplify this. Now when they said don't use mathematical tables, it implies that they want you to show the knowledge of indices. Because some students, if you don't put there this word calculator, they'll just get a calculator and press the whole of this at once and give you the final answer. But with this word there, it implies that you have to use indices. So indices, this 0.25 is a quarter, this 1/64 is that, and this one also remains there. The next is to use indices. 4 is the same as 2 to the power 2, which is there, and 64 is the same as 2 to the power 6, which is there, and 128 is the same as 2 to the power 7, which is there. The next, I think you see that these are multiple powers. There's this power and there's also this power. Now this one can become the reciprocal of this will be 2 to the power -5. Sorry, 2 to the power -2. So when this one goes up, the power has to change sign. That is why at this step you are seeing here 2 to the power -2. Same applies to this. That's why you see here 2 to the power -6. Then this one, there are two powers. So this time this is -14. That is why you see here 2 to the power -14. Then these are two powers, so you multiply the 2 to come up with -4, which is there. These are also two powers, you multiply them to get this power -12, which is there. Then from there, you remember the rule of multiplication. This is the same base, so you have to add these two powers to come up with this. Now when I add these two powers, I'll come up with -16, which is there. Now from there, we shall use the rule for division. Rule for division says this index of the divisor is subtracted from the index of the dividend. Therefore, it will be -16 minus -14. Now this minus and minus gives you positive. Therefore, -16 plus 14 is -2. That is why you see here -2. Now to make this power positive, you have to get the reciprocal, and that will be 1/2 to power 2. And also we know that this one is the same as 2 multiplied by itself 2 times. So 2 times 2 is 4. That is why you see here 4. So basically that's what they mean when they say don't use mathematical tables or calculator. And now shall go to question 2. It says that evaluate this. So evaluate this is what is given. The first thing we need to know is that 9 is the same as 3 to the power 2 and 27 is the same as 3 to the power 3. Then from there, these are multiple powers. So this times this is a bracket. So this time it means that you will multiply this 2 by this and also this 2 by this. That is why you see here 2y plus 2. Then same applies to this denominator. Multiply 3 by this and also 3 by this to come up with 3y minus 3. Now from there you realize that this is same base. So rule for multiplication says that you add the powers. That is why you see here they are added. Then also this is same base. So the rule for division says you subtract the powers. That is why you see here we shall subtract and come up with this step. but you must be keen to put this bracket. Be keen to put the bracket. Why? Because if you don't put the bracket, this and this will not give you a positive, and that will be vague. Therefore, you must make sure that you show the bracket, and after the bracket you'll be able to carry out the algebra very well. So this 3y and this 3y cancels, and this one plus this, because there's a negative here, it becomes 5. Then next we shall go to question 3, which says that simplify this. So this is what is given. First we shall use the indices. 8 is the same as 2 to the power 3, and 16 is the same as 2 to the power 4, 4 is the same as 2 to the power 2. The next is multiple power, so this times this, that is why you see here 3n, this one is okay. Then this times this, that is why you see here 8n, and this times this, that's why you see here 2 minus 4n. Then you realize that they are same bases, so same base for this and this. The rule for multiplication says that you add the powers, so I order to come up with this. Also the denominator, you add the powers to come up with that. And when you simplify, you'll be able to come up with that. Now the next we shall use the rule for division, where we shall subtract the powers. So when you subtract, come up with this, and simplifying, this and this cancels. Then negative 1 minus 2 gives you negative 3. Then to make this negative power positive, you have to get the reciprocal. Now this 2 to the power 3 is the same as 2 multiplied by itself 3 times. So 2 times 2 times 2 gives you 8. That is why you see here 8. Next we shall go to question 4, which is that simplify this. Now in math, for A-level math, when you see this dot, it implies multiplication. In O-level, the dot would mean operators. They could use star, hash, and other symbols, but in A-level, as long as you see the dot, just know that is another symbol to mean multiplication. Therefore, we shall come and rewrite it, and we put there what we know. So we know that this is multiplication. You shall come and replace the dot with a multiplication so that it doesn't confuse us. The next is to remember that 27 is the same as 3 to the power 3, and this 9 is the same as 3 to the power 2. Now after that, this 6 is the same as 2 times 3 to the power 1. So 2 times 3 gives you 6. That is why we have put here, where there is 6, we have put there 2 times 3 to the power 1. And this one can be expanded to, now we are doing the reverse of the rule for multiplication. So this one is the same as this 3 with this power multiplied by 3 with this power. Same applies to the denominator. Now this one is the same as, remember, this 2 multiplied by this and also by this. Therefore, the first 3 will have the power of 2n, and the other 3 will have a power of 2 times 2, which is 4. Then also for this one, the same case, this type by this gives you this, and this by this gives you that. Now the good thing is that all of them are and have the same base. So what we are going to do, we have to simplify. Now when you look at this, you realize that here 3 to the power 3n is common, and also when you look at this one, it implies that this one is also common. So what we are going to do, we shall first pull them out. Now when we pull this one out, it implies that they remain for this. Now let's first deal with this part. This part with this power, to get what is here, I will say this divide by this. Now when I divide, this one cancels, but this one, same base, you separate the powers to come up with 3 to the power 2. That is why you see here 3 to the power 2. Then you shall also deal with this and this. So this divide by this, you realize that this cancels, this one also cancels, then you remain with 2. That is why you see 2 here. Then from there, realize that when you compare the numerator and denominator, this and this can cancel, this and this can cancel. So you are going to remain with 3 squared minus 2. Now 3 squared is 9, minus 2 gives you 7. So now let's deal with fractional indices. We have been dealing with indices, which are whole numbers. What if they are fractions? So as long as there's a fraction, it implies that if the if it is a to power 1 over n, it is the same as nth root of a. Therefore, if it is a to power half, it implies square root of a. Note that the laws of indices apply to both positive and negative fractional indices. I think you have already seen that. So with that knowledge, let's go through this question. Question 1 says, evaluate without using calculators this. So first of all, 0.4 is the same as 4 over 10, and this one is the same as 125 over 1000, and this one is the same as 5 over 2. Now when I reduce, this one becomes 2 over 5, and this one becomes 25 the same as 5 to power 3, 1000 the same as 10 to power 3. And now this one, I think you realize that the power was negative. To make it positive, you have to get the reciprocal of this. Now the reciprocal means this one goes up and this one goes down. That is why here you see 2 over 5. Now this power, we are doing now the reverse of division with different base and same power. This power affects both of these ratios. Therefore, this will become 2 to power 2 and this will become 5 to power 2. Then here, this power with this is 1 and this power with this is also 1. That is why you see here 5 over 10. Then here this power affects both, so this will become 2 to power 3 and this becomes 5 to power 3. Now to make this division multiplication, you have to get the reciprocal of this. So the reciprocal means this one goes up and this one goes down. That is why you see here 5 to power 3 over 2 to power 3. So now we shall use same base. Remember same base. So same base, when you look at, there is this one and this one and also this one. But remember, these two are under the division, therefore that's why you see here this one is positive, then minus this is 2 to power 1, so the power will be negative 1, 2 to power 3, so the power will be negative 3. Then here you have this one which is positive and also this one which is negative because it is in the denominator. So when you simplify, we shall come up with 2 to power negative 2 multiplied by 5 to power 1. Now this one is a negative power. To make it positive, you get the reciprocal. Now this reciprocal, this is 4 and this is 5, therefore in the end we come up with 5 over 4. So that is how we deal with fractional powers. Question 2 says, without using tables or calculator, evaluate this. So we shall first write what is given and simplify. 16 is the same as 2 to power 4, 64 is the same as 2 to power 6, and this 8 is the same as 2 to power 3, to 125 is the same as 5 to power 3. Now next is, these are multiple powers, so this times this, that is why you see here 4 times a half. Then this times this, that's why you see here 6 times negative a third. Then also here, this times this gives you this, and also this times this gives you that. Now when you simplify, this one, 4 times a half is 2, that's why you see 2 there. Then this one also is negative 2, that's why you see negative 2 there. Then this is 2, that's why you see 2 there. And this is also 2, that's why you see 2 there. So 2 to power 2 is 4. Then this one is a quarter, I think by now you know it. Then now this one, 2 to power 2 is 4, and 5 to power 2 is 25. Now because they said we don't use calculators or table, we have to show the part of LCM. So the part of LCM, the LCM of this is 1, LCM will be 100. Now 100 divided by 1 is 100, 100 times 4 is 400. Then 100 divided by 4 is 25, 25 times 1 is 25. Then 100 divided by 25 is 4, 4 times 4 is 16. Then when I add these ones, I come up with 441, and divide by 100 becomes 4.41. So when they say that you don't use a calculator, this part of LCM must be seen. So now we shall go to question 3, which is that simplify this. So this is what we are given. Now next we shall see that 12 is the same as 3 times 4, therefore that 3 is there, and that 4 becomes 2 to the power 2. Then 16 is 2 to the power 4, 27 is 3 to the power 3, 18 is the same as 2 times 9, but that 9 is 3 to the power 2. Now these are different bases but same power, so we are doing the reverse. So this to power this gives you this, and this power this gives you that. Then this power that gives you this. Here it is the same, but here this is 2 to the power half and this is 3 squared power half. Then next we remember the rule for multiple powers, so this one is okay, but this one will be this times this to come up with 3, which is there. Then this one will be this times this to come up with a half, which is there. Then this one this times this will come up with a half, which is there. This one is okay, a half, and this one is also this times this to come up with 1, which is there. Then next is to look at the same base. So this and this same base, to add the powers to come up with that. Then also here this with this same base, you add the powers to come up with that. So this plus this gives you 7 over 2, and this plus this gives you 3 over 2. Then next is to, now this one cancels, you remain with only this 2 which is there. Same base, we subtract the powers to come up with 2 to the power 3. So now we shall go to question 4, which says that x simplify this expression. So that is what we are given. Now we have to simplify. Now simplifying, what we are going to do, we are going to first expand the upper brackets. Expanding means that this one multiplies the whole of this bracket, and that is what is here. Then plus, there is a plus here, so the plus is maintained. Then this one multiplies with the whole of this bracket, this is what you see here. Then for this one, we should remember the identity for expanding a plus b squared. When I expand a plus b squared, it becomes a squared. Now this is a squared plus 2ab plus b squared. Now a squared, this, when I square this, I'll come up with x cubed. The next part is 2ab. Now 2 times this, this is what you see here, 2 times that times that. Then plus b squared, square of this one gives you x to the power 1. Okay, now we have dealt with the denominator. What about the numerator? Numerator, this times this, same base, you add the powers to come up with x power 2. Then also this times this, same base, you add the powers to come up with x plus 1. But remember, there's a minus. Then here there's a plus, which is here. Then this times this, you same base, add the powers to come up with x power 1. Then there is also this minus. Then this times this, same base, you add the powers to come up with x power 0. For the denominator, you are going to simplify. Now when I simplify, you come up, we realize that this times this is same base, so you add the powers to come up with x squared. That is why you see here x squared. Then for this numerator now, this one and this one can cancel. So, and you also know that any number power 0 is 1. That is why you see this one there and this one is here, but this negative has to be maintained. Now that is the numerator. What about the denominator? Denominator, you will realize that x is common, so you factorize out x. This will remain x squared, this will remain negative 2x, and this one will be remain 1. Now for the numerator, there is difference of 2 squares. So difference of 2 squares gives you this difference and addition. Then for the denominator also, this one can be factorized because the sum is 1 and the sum is negative 2 and the product is 1. Therefore the factors will be still the same, negative 1, negative 1. That is why you see here it is a repeated root, repeated factor. Now from there, realize that this and this one power can cancel, so remain with x plus 1 over x minus 1. So that has been fractional indices. Now we shall go to equality of index expressions. Here we shall say that if two index expressions are equal and their bases are the same. Note this word equal, index expressions and also same base. It implies that the indices of these expressions are also equal. For example, if I have c to power a and is equal to c to power b, you realize that this base is the same. As long as it is the same, it implies that even these powers are the same. That is why you see here that a is equal to b. Now that knowledge shall go through some of the questions for you to master the concept. So question 1 says, solve for x. We are given 2 to the power 2x equal to 16. Now 16 is the same as 2 to the power 4. Now after that you realize that this is the same as this, implying that it can cancel and the powers also be the same. Therefore 2x will be equal to 4. Making x the subject, x will be equal to 2. Now we shall go to question 2, which is that given that this is equal to this, find the value of x. So still the same. That is what is given. Then this one is the same as 1 over 5, which is 5 to the power negative 1, and this one is 5 to the power 2. So multiple powers, you multiply them. So this times this gives you negative 5 over 2, this times this gives you 2x. But the bases are the same, so it implies that negative 5 over 2 is equal to 2x. And when I make x the subject, x will be equal to negative 5 over 4. So now we shall go to question 3, which says that solve the equation this equal to that. So first of all, 125 is the same as 5 to the power 3, and 25 is 5 to the power 2. Therefore this side same base, so you have to add the powers to come up with this. And then you come up with 5 to the power 10, and here for this side it is multiple powers, so to multiply them to come up with 2k. Then at this step, 5 is, the base is common, so it implies that 10 is equal to 2k. And when I make k the subject, k will be equal to 5. Then question 4 says, given that this is equal to that, find the value of y. So first of all, this 1 over 8 is the same as h to the power negative 1, and 8 is the same as 2 to the power 3. Therefore, we shall come up with 2 to the power negative 3 as 1 over 8. Now, same base, you have to equate also the powers. That is why you see here 2y is equal to negative 3. Then making y the subject, y will be equal to negative 3 over 2. And now we shall go to question 5, which says that find the values of x and y such that 2 to the power x multiplier, so that this dot means multiplication in Alevel. So 2 to the power x multiplied by 3 to the power y is equal to 432. Now first of all, you shall remember that 432, when you prime factorize, it will be equal to 2 to the power 4 multiplied by 3 to the power 3. After that, we shall just compare, because this and this, it implies that x is equal to 4. Then this with this, it implies that y is equal to 3. So basically that's what they wanted. So now we shall go to indices reduced to quadratic equations. So I believe you remember how to solve quadratic equations in O-level. So that knowledge for solving quadratic equations will be used also in this part. Now question 1 says, question 1 came from UNEB 2017 paper 1 question 4 and says, solve for x in the equation that. So the first thing to do is to, this is what is given, but you also remember that this one is the same as this. We are doing the reverse, and this one is the same as that. After that, we shall let y to be equal to 4 to the power x. Then we shall come and substitute. Where there is 4 to the power x, we put there y, there is a square, that's why you see we are y squared. Here there is 4, and here there is y. So what you have got is a quadratic equation. So that is why the topic says that indices reduced to a quadratic equation. So it was initially an index, but indices, but now it is a quadratic equation. So what we need to remember, the knowledge for solving quadratic equation, you can either use factorization or use bulldozer method. Now when I use factorization, I realize that this is the same as this, because the factors, you have to look for factors whose sum is negative 4 and product is 4. Those factors are negative 2 and negative 2, which means that is a repeated factor. That's why you see here y minus 2 to power 2. That means that y is equal to 2. But remember, in the question there is x. We are the ones who introduced in the y. So we have to go back and substitute for y to be able to come up with the value of x which they want. So when y is equal to 2, it implies that 4 to power x is equal to 2 because y is equal to this. And this 2 is the same as 2 to power 1. Therefore, same base. It means that even the powers are the same. That is why you see that 2x is equal to 1. Now when I make x the subject, x will be equal to a half. And now we shall go to question 2, which came from UNEB 2012, paper 1, question 15a, and says, solve for x in the equation that. So you first write the given equation, then you simplify. This one is the same as, remember 9 is 3 squared, so I can rearrange these powers because it's a product. So this x can come inside and the 2 goes outside. Then this one is the same as 3 times 3 to power x. You should be keen of the bracket. This bracket I'm using is very vital. Now let y be equal to this which is in the bracket. Therefore, come and substitute and come up with a quadratic equation. So next is to solve the quadratic equation. Like I said, you can either use factorization or bulldozer method. In question 1, we used factorization method. Now in question 2, let's also see how bulldozer method is used. So you can substitute negative b. This is b is negative. Sorry, let's start with a. So in this case, the coefficient of y squared is a, which is 1. Coefficient of y is negative 3, which is b. And the one without y is negative 10, which is c. Now the formula says negative b. Now negative of this is positive 3. Then square root of negative b squared. So square root of b squared. Now b squared is negative 3 squared. But you must be keen of the bracket. Even the negative is under the square. Then minus 4ac. Now a is 1 and c is negative 10. Over 2a, a is 1. So that is how you substitute, and when you use a calculator, you'll come up with two values of y. One y will be equal to 5, another y will be equal to negative 2. But remember, in the question they didn't ask for y, so we have to substitute and get the value of x. So when y is equal to 5, it implies that 3 to the power x is equal to 5. And what does that mean? Now here there is no, you cannot prime factorize this in terms of 3, therefore you have to use logarithm. Now put log on both sides, you'll come up with x being equal to log 5 over log 3. And when I use a calculator, I'll come up with 1.465. What about when y is equal to negative 2? When y is equal to negative 2, 3 to the power x is equal to negative 2, and that is undefined. So x is undefined. So now we shall go to question 3, which came from UNEB 1999, paper 1, question 10a, and says, solve the equation this. So that is what is given. So we shall come and substitute. Let y be equal to 3 to the power x. Therefore, this becomes that, and this is maintained. Now we have got a quadratic equation. We can use either bulldozer or factorization. When I use bulldozer, I'll come up with two values of y. One will be 2, another one will be a half. What about the corresponding value? So when y is equal to 2, 3 to the power x is equal to 2, implying that x is equal to log 2 over log 3, which is equal to 0.6309. What about when y is equal to a half? It implies that 3x is equal to 0.5. Therefore, x is equal to log 0.5 over log 3, which is negative 0.6309. And now we shall go to question 4, which came from UNEB November 1998, paper 1, question 10a, and says, solve this. So still we shall go through the same procedure. Since here the lowest base is 2, we shall also express this in terms of 2, so it will be 2 to the power 2x. Therefore, let y be equal to 2 to the power x. To come out, this becomes that, and this is maintained. Now that is a quadratic. You can either use bulldozer or factorization. Now when I use bulldozer, the values of y will be y equal to 5 and y equal to negative 3. So when y is equal to 5, it implies that 2 to the power x is equal to 5, implying that x is equal to log 5 over log 2, which gives you 2.3219. What about when y is equal to negative 3? As long as this is negative, it implies that x is undefined. And now we shall go to question 5, which came from UNEB 1997, paper 1, question 9b, Roman 2, and says solve this. So we first write what is given, then we try to simplify. Now this one is the same as that, and this is the same as that, and this is the same as that. So now we shall say that let y be equal to 2 to the power x. Therefore, come and substitute for y here and substitute for y there. Then multiply followed by the LCM to come up with that, rearrange to get a quadratic equation, and solve the quadratic equation using either factorization or bulldozer method. Now when I use bulldozer method, y will be equal to 3 or 1. Therefore, when y is equal to 3, 2 to the power x is equal to 3, implying that x is equal to log 3 over log 2, which is 1.5850. And when y is equal to 1, it implies that 2 to the power x is equal to 2 to the power 0, implying that x is equal to 0. So now we shall go to question 6, which came from UNEB 1996, paper 1, question 1, and says solve this. So that is what is given. So we shall come and say that let y be equal to 3 to the power x. Therefore, we shall come up with this quadratic equation. Then solve it when I use bulldozer method. The values of y will be y -1 and a third. For y equal to -1, as long as it's negative, it implies that x is undefined. When y is equal to -3, it implies that 3 to the power x is equal to 3 to the power -1. Therefore, x is equal to -1. So now we shall go to indices involving simultaneous equations. I believe you have already covered the topic of simultaneous equations because it is also available on this platform. So the knowledge you covered in simultaneous equations is the same knowledge you are going to use here. So question 1 says solve simultaneous equations this. So what you're going to do, we shall say that let a be equal to 2 to the power x and b be equal to 2 to the power y. Therefore, from equation a, this becomes a, and this one, remember, it is 2 to the power 2. Therefore, 2 to the power y is b, but there is also another 2, which is a power, and that is why you see here b squared. This 12 is maintained. That is equation 1. What about equation 2? This one becomes that, and this one becomes that. So now this, it is you to choose whether to use substitution method or elimination method. So if I use substitution, I will say multiply 3 throughout equation 1 and subtract equation 2 from it. So when I do that, I'll come up with 5b squared equal to 20. Divide by 5, you come up with b squared equal to 4. Then put square root on both sides, you come up with b equal to plus or minus 2. Now from equation 1, when I come from this equation 1, I'm able to get the value of a. So come and substitute for this b here, it will become a to power a plus 4 is equal to 12. Therefore, a is equal to 8. But remember, these a and b, we are the ones who introduced them there. The value they want is for x and y. Therefore, for a equal to 8, you'll come here and say that 2 to the power x is equal to 8, which is 2 to the power 3. Therefore, same base, it implies that x is equal to 3. Then for b equal to positive 2, it implies that 2 to the power y is equal to 2 to the power 1, which is therefore y is equal to 1. What about for b equal to -2? For b equal to -2, you come up with 2 to the power y equal to negative. As long as it's negative, it implies that y is undefined. Then now shall go to question 2, says solve the simultaneous equations this and that. So from equation 1, this is the equation we are given. We are going to simplify it. 27 is the same as 3 to the power 3. 9 is the same as 3 to the power 2. Therefore, multiple powers, multiply them to come up with this and also this. Now, same base, you cancel them and you equate the powers. Rearranging, you come up with x equal to -5y and call it equation 1. What about from this equation? From this equation, this 64 is the same as 2 to the power 6. Therefore, same base, you equate the powers to come up with that. Now we have 2 equations and 2 unknowns, so we shall substitute equation 1 into equation 2. So where there is x, we shall put there -5y to come up with this step. Then expand to come up with that, divide it by 24. When I divide, I'll come up with that. So here I'll reduce. 24 divided by 6 gives you 4, and this is 1. Now when I make y the subject, y will be equal to plus or minus 0.5. Now from equation 1, I can be able to get the value of x given y. Therefore, when y is equal to negative 0.5, x is equal to 2.5. What about when y is equal to positive 0.5? X will be equal to negative 2.5. So that has been indices. Now we shall go to the part 2, which is surds. Now surds, they are the very surds you covered in O-level, so only that here we make them a little complicated, but they are the same surds. So let's try to go through this statement. So expressions such as square root of 4, square root of 9, square root of 16, etc. can be evaluated exactly and have exact numerical values. For example, square root of 4 is the same as plus or minus 2, square root of 9 is the same as plus or minus 3, square root of 16 is the same as plus or minus 4, and so on. However, expressions such as square root of 2, square root of 3, square root of 5, etc. cannot be evaluated exactly and hence cannot be written numerically as quantities. What does that mean? It implies that they are irrational and can only give decimal approximations. For example, when you use a calculator, square root of 2 will give you this number of decimal places, square root of 3 will give you this number of decimal places, and square root of 5 will give you this number of decimal places, and so on. Therefore, such irrational expressions are known as surds. So these are what we call surds. And they often arise in calculations, and it's often preferable to leave an answer in surd form instead of its decimal approximation. Now here it must be noted that even though it is correct to leave the answer in surd form, the surd must not remain in the denominator. The surd should not remain in the denominator. However, expressions involving surds have to be simplified following certain rules. So there are some rules we need to follow when dealing with this topic of surds. So now let's start with the reduced form of a surd. So we have said that surds can be reduced to their simplest form if. So this word is if. So if the number under the square root sign is a product of a square number and any other number. For example, if I have the square root of a squared times b, it can be reduced to become a square root of b. For example, if I have square root of 175, 175 is the same as 25 times 7, but this is a square number, therefore it is the same as 5 squared, and therefore in the end you come up with 5 root 7. The next is multiplication and division of surds. So surds of the same order can be multiplied or divided. For example, if I have root a times root b, the same as root of a times b under the same root. Then also root a divided by root b, the same as square root of a divided by b. For example, if I have root 7 times root 2, it is the same as square root of 7 times 2, which is square root of 14. And also root 15 divided by root 3 is the same as square root of 15 divided by 3, which is the same as root 5. So furthermore, this times this, it implies that these ones outside can be multiplied together to come up with this, and also these ones inside can be multiplied together to give you that. For example, if I have this, it implies that this times this gives you this, which is 6, and also this times this gives you this, which is root 14. Then next we shall go to addition and subtraction of surds. Now surds of the same order with the same number under the root sign can be added or subtracted. For example, this and this, we realize that this is root c and also this is root c, meaning that you can add them by saying this time plus this gives you that, and this one is maintained. In other words, factorize out root c. Similarly, this minus this implies that this and this can be subtracted because you have factorized out root c. For example, this will give you that because this is 7 plus 5 gives you 12. Then your 7 minus 2 gives you 2. So that is how they subtract or add indices or add surds. But remember, you must be keen, because when it becomes root a plus root b, there's no way you can add it, and also root a minus root b, there's no way you can subtract it. So with that knowledge, let's go through some of the questions. Question 1 says, without using tables or calculator, simplify this. So first of all, we have to remember that to simplify them to be a product of a square number and any other number. So this 243 is the same as 81 times 3, 108 is the same as 36 times 3, 75 is the same as 25 times 3. So these are square numbers. Therefore, square root of 81 is 9, that is why you see 9 here. Square root of 36 is 6, that is why you see 6 here. Square root of 25 is 5, that is why you see 5 there. Then next, this minus this plus this gives you this part. And in the end, you shall come up with 8 root 3 as the answer. Then question 2 says, simplify this, leaving your answer in surd form. So this one, 45 is the same as 9 times 5, 20 is the same as 4 times 5, 80 is the same as 16 times 5. Now these ones are square numbers, so inside one should be a square number and one should be, and the other should be any other number. So square root of 9 is 3, that's why you see 3 there. Square root of 4 is 2, that's why you see 2 there. Square root of 16 is 4, that's why you see 4 there. So next I'll simplify. This gives you 6. And then this plus this minus this is this part, therefore answer will be 4 root 5. Then question 3 says, express the following in the simplest form. Now this one, 288 is the same as 144 times 2. This 2 is maintained. 72 is the same as 36 times 2. Therefore, square root of 144 is 12, that's why you see 12 there. Square root of 36 is 6, that is why you see 6 there. The next is this plus this minus this to come up with this part, and the answer will be 13 root 2. Then question 4 says, express this in the form a root b. Given that root 2 is 1.414, evaluate the above expression. So this is what is given. Then from here I realize that this one can be simplified to become this, and this one can be simplified to come up with this. And also this one will be simplified to come up with this. I believe by now you know how to simplify them. So next is to collect like terms, because this is root 2, root 2, root 2, root 2. Therefore it will be this 10, which is here, minus 3, plus 20, minus 6. And then you come up with 21 root 2. So it is already in that form. But they told us that given root 2 is equal to that, evaluate the above expression. Therefore, the above expression will be equal to 21 root 2, which is 21 times 1.414. And when I use the calculator, it will become this. Then question 5, without using a calculator, evaluate this. So when they say without using calculator, it means that they want to see the laws of surds being applied. So this is what is given. This will be maintained, but this 40 is the same as 4 times 10, and this 20 is the same as 4 times 5. Therefore, square root of 4 is 2, that's why you see 2 there. Square root of 4 is 2, that's why you see 2 there. So this is 6 plus 4, which is 10, and this is 2, which is there, and this times this gives you root 10, which is there. Now this can cancel to remain with 10 over 5, which is, 10 over 2, which is 5. And question 6 says, given that t is equal to this, show that t squared is equal to 1 plus t. Therefore, we shall start from the left hand side. T squared is equal to the whole of this squared, which is that. Then when I expand, it will be giving me that, because this half becomes a quarter, and expanding this one gives you this. I hope you remember the expansion of a plus b squared. Then when I collect like terms, this plus this gives you 6, and this is maintained. But remember, t is t, inside there is only 1 plus root 5. So this one, what I've done, this 6 and this 2, they have something in common, and that is 2. Therefore 2 can be factorized out to cancel with this, to cancel 1 2 here, to remain with a half, and the inside will remain, this 6 will become 2, so it will become 3, and this 2 will become 1. But in our expression for t, after this root 5 there is only 1. That is why we are going to split this 3 into 1 plus 2. Then we split it, this 1 times a half to give you this, and this 2 times a half to give you that. Then this one is 1, and this one is t. And basically that is what they wanted. So now we shall go to rationalizing the denominator. So the process of converting an irrational denominator to a rational one is known as rationalization. When fractions are involved in surds, it is normal practice to eliminate the surd from the denominator. Like I've already said, the answer can be left in surd form as long as the denominator does not have a surd. So in case the denominator has a surd, what you need to know is how to rationalize. So this is what we are going to deal with. So this is called rationalizing the denominator, and the aim is to ensure that the denominator is clearing of irrational numbers now that it doesn't have any surd. Now let's start with case 1, whereby you have an expression of the type 1 over root a. So for expressions of this type, we multiply the numerator and the denominator by root a. For example, if I have 1 over root a, it means that I have multiplied up and down by this root a to come up with root a over a. And in this case, I think we realize that the denominator does not have any surd. Now that knowledge, let's go through some of the questions. Question 1 says, simplify this by rationalizing the denominator. So rationalizing means that you multiply up and down by this one to come up with this step, and here we realize this 2 is maintained. Now 2 times 8 gives you 16, and 8 times 8 gives you 64. Therefore in the end we shall come up with 2 times 4 over 8, which gives you 1. Question 2 says, show that this is equal to root 2 over 2. So here we have to also remember the knowledge of surds. So this one is the same as 5 to the power 2. And also this one, you realize that 5 to the power 6 is common, so instead you shall remain with 5 to the power 1 minus 5 to the power 0. So how does it come about? Now to get this one, you say this divide by this. So when I divide, same base subtract the power, will come up with 5 to the power 1, which is there. Then this minus is maintained. Then this divide by this, same base subtract the power, you come up with 5 to the power 0. Now this one is the same, it will become this because you multiply the power, so come up with 5 to the power 6. And here, this is 5 to the power 6, and this minus this. Remember, this is 5 minus 1 gives you 4. Then this times this, it becomes 2 times 5 to the power 6, and this one is maintained here. Then you are going to cancel out, because this and this cancels. Then this 2 divided by 4 gives you a half. That is why I see a square root of a half. But remember, in this square root of a half, root 2 is in the denominator, therefore you have to rationalize. So multiply up and down by root 2 to come up with root 2 over 2 as required. Then question 3 says, without using mathematical tables or a calculator, find the value of this. So you write the given expression and also expand. Remember, this is the difference of two squares. So one bracket will have a subtraction, another one will have addition. Then when I simplify, this time this and this cancels, so negative 2 minus 2 gives you negative 4. Then also here, this one cancels, you remain with root 2 plus root 2, which gives you root 5 plus root 5, which gives you 2 root 5. Now this root 5 can cancel with this, and this one, negative 8 over 8, gives you negative 1 as the answer. So that was case 1. What about case 2? Case 2 is the denominator which is in the form a plus or minus b root c. So when the denominator is in that form, where a, b, and c are integers, we multiply both the numerator and denominator by the conjugate surd of the denominator. So conjugate surd means that for this one, so it means that this is the conjugate side of this, so you just change the sign. If here there is minus, here to be plus, and also if here there is plus, here there will be minus. For example, if I have this one, the conjugate side will be a minus b root c, which is here, but multiply both up and down. When I open brackets, this will becomes this and this one. The denominator will be difference of two squares, so it will be this squared minus this squared. In the end, you come up with this. I think we realize that now the denominator does not have any sides, so that is how they rationalize sides with the denominator of that form. Now let's go through some of the questions. Question 1 says, express this in the form this, and then find b over a. So in this case, the conjugate side is 3 plus root 2. That's why I multiply both up and down. Then when you expand, it implies that this times this gives you 9. Then this times this gives you 3 root 2, and also this times this is 3 root 2, so when you add the 2 will come up with 6 root 2. Then this times this gives you 2, which is here. For the denominator, it is difference of two squares, so this squared is 9 and this squared is 2. So collect like times this plus this is 11 and this is 6 root 2. Then this one is 7. But I wanted it in this form, meaning that we have to split the numerator. Splitting means that this will be over this and also this will be over that. That's why you see here 11 over 7 plus 6 over 7 root 2. Now that means that our A is this and B is that. Therefore the hence part, B is this, come and put it here, divide by A, which is this. You will come up with 6 over 11. So now we shall go to question 2, which is that without using tables or calculator, simplify that. So this is what is given, and this is the same as 25 times 3, this is the same as 16 times 3, this is the same as 100 times 3, this is the same as 25 times 3. So simplifying gives you that you can split the square roots, then this one gives you 5, this one gives you 4, this one gives you 10, this one gives you 5. So this one, this plus this is 9, and this minus this is 5. So the sides are the same, so they can cancel, remain with 9 over 5, which is the same as 4 over 5. Now we shall go to question 3, which is that given this is equal to this, find the values of P, Q, and R. So we're going to start with the left hand side. So this one, we are going to rationalize the denominator to come up with this step. I think we see that this was minus and the side conjugate is, sorry, this was plus, side conjugate will be minus. So when I expand, I'll come up with that in the numerator and this in the denominator. So simplify and collect like terms, will come up with this, which is equal to that. Then at this step, we have to split the numerator because you should see here it is split. So it will be this over this, which gives you that, minus this over this, which is that. Now when I reduce, this can be reduced to become 9 over 11, and this 12 over 33 can be reduced to become 4 over 11. Root 15 cannot be reduced. Therefore, P is equal to this, and Q is equal to that, and R is equal to that. Now we shall go to question 4, which is that given that root 15 is that, root 6 is that, and root 10 is that, without using calculator, evaluate this. So first is to rationalize and then expand both the numerator and also the denominator, then simplify to come up with that. Then from there, remember this initial condition, initial value is given, so I'll come and substitute for root 15, substitute for root 6, substitute for root 10 to come up with what is required, and that will be 0.387. Then question 5 says evaluate this given that root 5 is that and root 3 is that. So first of all, I'll get the LCM. LCM will be this times this, which is that. Then this part will be got by saying this times this, that's why you see it here, and also this times this to get this part. So expand and open brackets, you'll come up with this step. Therefore 5 minus 3 is 2, and we are given that root 5 is this and root 3 is that, so I'll come and substitute to be able to get that value. So now we shall go to question 6, which says that express as equivalent fraction with a rational denominator. Express this. So what you are going to do, we are going to first pair. Take this one as one term, then you say a minus b gives what? So when you take it as one term, you realize that we will be able to get the difference of two squares in the denominator, then the numerator will be that. So expanding the numerator gives you this, and denominator is difference of two squares, so it will be this squared minus this squared. Now when I square this, I'll come up with this part, and when I square this, I'll come up with 5. So in the end, simplifying will give me this part. But remember, the stud cannot be left in the denominator, so I have to multiply up and down by this root 6 to come up with this expression. So in the end, I can simplify to come up with this. So now we shall go to surds reduced to quadratic equations. So here we shall start with question 1, which says solve this expression. So this one, the first thing to do is to put one side on the other side, and after that we shall square both sides. Squaring this gives you this, and squaring this gives you that. I think you remember that expansion. Therefore, what we are going to do, take the whole of this on one side and this one on the other side to come up with 2x plus 6 equal to 4 root 3x plus 4. Now there is still this side, so you still have to square both sides. So when I square both sides, I'll come up with that. So what I've done here, I think we realize that this was 2x plus 6 and yet is x plus 3. Why? Because this I've reduced both sides by 2. So divide this by 2 gives you x plus 3. Divide this by 2 gives you 2 root that. So when I square and expand, this side gives me this, and this gives me that. So now I have to open brackets and also factorize this quadratic equation. So this quadratic equation is this, and when I factorize it, it becomes that. Therefore, x is equal to 7 or x is equal to negative 1. But this is not the end. You have to verify to find out which of these two is correct. So if I start with x equal to 7, it implies that I'm going to put 7 here and also here to see if it gives me 2. So it gives me 8. What does that mean? It means that 7 is not required. What about negative 1? When I put negative 1, I'll come up with 2, which is here. Therefore, the answer is x equal to negative 1. So remember, this part of verification must be seen. So now we shall go to question 2, which is that solve for the value of x in the equation that. So still we shall go through the same step. One is take one side on the other side, and then put square on both sides, and then you expand, collect like terms. So when I collect like terms, I'll come up with that. Then there's still a side, so I'll still put square on both sides to come up with a quadratic equation. Now that quadratic equation has to be solved either by bulldozer method or factorization. When I use factorization, 1x will be 14 and the other one will be 6. So after getting the values of x, you have to verify which is correct. So let's start with the one of x equal to 14. So put 14 here and here and see if you come up with 3. So I'll come up with 3, meaning that x is equal to 14. What about x equal to 6? Put it there and see you'll come up with negative 3, meaning that x is not equal to 6. So now we shall go to question 3, which is that solve this equation, solve this expression, and verify your answer. So here, already one side is this side, so what we shall do, we shall just square both sides. So when you square, we shall come up with this expansion here and this here. Then collect like terms so that the side remains only on one side and the others go on the other side. Square both sides and expand to come up with that. Collect like terms to get a quadratic equation, solve it by either bulldozer or factorization method and get the values of x. Now still you have to verify. So in verifying, you'll come here and say, now here in this case both sides were on both sides, so what we shall do, shall substitute for x equal to 3 on both sides to come up with this step, simplify, and you realize that 1 is equal to 1, therefore it is true. If it is true, it implies that x is equal to 3. What about when x is equal to negative 2? Substitute and simplify and see if it is also true. In this case it is false, meaning that x is not equal to negative 2, therefore you shall come and conclude that x is not equal to negative 2 but is equal to 3. Then question 4 says solve the equation this. Still both sides are on both sides, so the first thing to do is to square both sides. Then open brackets, expand, simplify, and then rearrange to make side on only one side. And in that case, after that you shall square both sides. So when you square, you'll come up with a quadratic. Then solve that quadratic by either factorization or bulldozer method. Then you have to verify. So verifying, shall come and say that for y equal to negative 7, come and substitute for y and simplify to see if it is true. So it is false, meaning that y is not equal to negative 7. What about when y is equal to negative 2? Substitute and simplify. In this case, it is true, therefore y is not equal to negative 7 but it is equal to negative 2. So the step of verifying is very, very vital. So shall go to question 5 whether they want you to solve for that. So still shall do the same procedure, square both sides, expand, rearrange, then square again, collect like terms to get a quadratic, solve the quadratic. So this time we have used bulldozer method. So the values of x can be negative a third or 1. Then next we have to verify. So when you verify, so substitute for when x is equal to negative a third, you'll come up with that. Simplify, therefore it is true. What about when x is equal to 1? Simplify, it is true, meaning that x is equal to negative 3 and negative a third, and also x is equal to 1 are both correct. So now I shall go to part 3 of this video, and that is about logarithms. So a logarithm of a number to a given base is the power to which the base must be raised to give the number. Therefore, when a number is expressed in the index form, for example, if we have a to power x, and it implies that x is called the logarithm and a is called the base. That means that a to power x, if it is equal to y, then it will mean that log of y base a is equal to x. So if you have something like this one, it implies that log base 3 of 81 is equal to 4. So this will be the logarithm and this will be the base. So there are some rules which you need to know while simplifying logarithmic expressions. One is the rule for addition. So in this case, you must note that the base is the same. So it is the same and yet is addition, to imply that these two will be multiplied to give this. If the base is the same and this is subtraction, then these two will be divided to get this. And log base c of a to power n, this power can go this side to come up to become n log base c of a. And since we know that a to power 0 is already, a number to power 0 is equal to 1, then log base a of 1 is equal to 0. So this a can be any base. Then also we know that a to power 1 is equal to a, therefore log base a of a is equal to 1. Now this a and a can be any base also. But as long as they are similar, to cancel to give you 1. So sometimes they will give you logarithms without a base. So when the base is not implied, it implies that it is base 10. For example, here they just say log a, it implies log base 10 of a. So now let's go through some of the questions. Question 1 says, show that this is equal to that. So we shall start from the left hand side. Left hand side is that. Then we shall try to simplify. Now bring this one here, it becomes 4 squared. Then bring this half here, it becomes 25 squared. Because the number to power half is equal to square root. Now this 4 squared is 16, and this root of 25 is 5. Then from there we shall say this plus this, it becomes, these two will be multiplied, that's why you see this. Then this resultant minus this, it implies that this output will be divided by this 20. So when you try to cancel, you realize that this is 1, this is 4, then 16 over 4 will be 4. Now 4 is the same as 2 squared, and therefore bring this 2 comes this side to become 2 log 2. So now we shall go to question 2, which says that without using tables or calculator, simplify this. So that is what is given. Now this half, when it goes this side, becomes 1016 divided 1600 divided to power half, which is the square root. Then this 2 comes this side to become x over 5 squared. Now the whole of this will give you that. And this one, remember, it is division, meaning that when you expand it will be here subtraction. So this one, x squared, gives you this, and this 5 squared gives you that. So when I open this bracket, you realize that this minus now becomes plus because it is minus minus. Therefore this and this can cancel to remain with only this and this, which is that. So same base, it means that it should be this times this, which is that. And know that this gives you 1000. And 1000 is 10 to power 3, so this 1000 will become 10 to power 3. Then this power can go this side to become 3 log base 10 of 10. And we know that since these are the same, it implies that the whole of this becomes 1. And 3 times 1 is 3. So now we shall go to question 3, which says that evaluate that. So first of all, this 216 is the same as 6 to power 3, 64 is the same as 2 to power 6, 243 is the same as 3 to power 5, 0.1 is the same as 10 to power negative 1. So when I take this power down here, it will become this. Take this one here to become that. And also take this one here to become this. Take this negative here to become that. So next, this is 1, that is why you see here 3. This is also 1, that's why you see here 6. And this is also 1, that is why you see here 5. And this is 1. That is why you see here now negative and negative gives you positive. That is why there is plus there. So simplifying this will give you 1.5 as the answer. So now shall go to question 4, which is that given that p is equal to this and q is equal to that, find the value of p plus q. So we are going to first simplify p. So p is there, come and simplify it. This is multiplication, so that is why you see addition. Then this power can go this side to become this, and also this power can go this side to become minus 2. Now this one becomes 1, and also, so this one becomes 1, that is why you see here 3 minus 2 log base a of y. What about q? When we bring q here, so this is a product, so that is why you see addition there. Then this one becomes 1, and also this 2 can go this side to become 2 log base a of y. Therefore, we are told to get the value of p plus q, so come and substitute for p here and for q here and simplify. So when you simplify, you realize that the whole of this can cancel with this, and you remain with 3 plus 1, which is 4. So now we shall go to question 5, which says that express this as a single logarithm and simplify your answer. So this is what we are given, and we have to simplify. Now this square root is the same as the power half, therefore that power half can go this side to become a half. Log base 10, so when there's no logarithm, it is base 10 of x squared minus 1. Now this half is common in both, so I'm going to first pull it out and remain with this here and this here. Now this one is difference of two squares, that is why you see here difference and addition. Now here these two logarithms are they have a plus in between them, that is why you see here multiplication. So this and this will be multiplied to get a single logarithm. But they told us to simplify our answer, therefore you'll start simplifying. So that means that this cancels with this, and this one multiplied by this gives you x plus 1 squared, but the half is still maintained. So this power will go down and will get a half times 2 log base 10 of x plus 1. And this half with this one will cancel to remain with log base 10 of x plus 1. So now we shall go to logarithmic equations with similar base. Sometimes the bases will be different, but let's start with the one which has similar base. So question 1 says that given that log base 3 of x is equal to this, find the value of x. So we shall first rewrite what is given, then we start using the rules. For example, this 2 can go this side to become 4 squared. Then we also remember that in BODMAS we start with addition, then we go to subtraction. So this one addition will come here, and this subtraction will be last. Therefore you will come and say that this is 16 times 9 over 5, which is this. So when I simplify this, I'll come up with that, which is 28.8. And lastly, this log 3 can cancel because here there is no coefficient, and also here there is no coefficient. Therefore you end up with x being equal to 28.8. Now we shall go to question 2, which is that solve for a in this. So that is what is given. Next is to say that this a to power 2 is equal to this. This is what is here. So next is to form a quadratic equation and simplify it, factorize it, or use bulldozer method to get the values of a. So when I factorize, I'll come up with a plus 3, a minus 2 equal to 0. And that implies that a is equal to negative 3 or a is equal to 2. Now we shall go to question 3, which is that prove that log base c of ab is equal to log base c of a plus log base c of b. And then solve the equation this. So let's start with the part of proof. Proving, which has that let x be equal to this log base c of a, implying that c to power x is equal to a, which is there. Then also let y be equal to log base c of b, implying that c to power y is equal to b, which is that. So equation 1 multiplied by equation 2, we shall be able to come up with a times b this side and c to power x multiplied by c to power y. Now same base, you add the powers to come up with c to power x plus y. So putting log base c on both sides will give us log base c of ab is equal to log base c of c to power x plus y. Now this power can also go this side to become this x plus y in brackets multiplied by log base c of c. And you also know that the whole of this becomes 1, therefore you end up with x plus y. And the good thing, we know that x was this and y was this. So what does that mean? It means that this one is equal to that as it was required. So now we shall go to the hence part. So for the hence part, that is what was given and we have to solve it. So this addition means that here it will be multiplication. Difference of two squares, we come up with x squared minus 4. Then it implies that the 8 to the power 3 is equal to x squared minus 4, as you can see it here. So 8 to the power 3 is equal to 512, and x squared will be equal to 516 when I take this for this side. Putting the square root will give me the value of x, and it will be 22.7156. So now we shall go to question 4, which says that solve the equation this. So that is a given equation, you have to solve it. So this, as long as there is plus here, it will be multiplication there, and that gives you that. Therefore, to eliminate the logarithm, we shall say 10 to the power 1 is equal to this, as you can see it there. Expand, you'll come up with that. Then you'll come up with a quadratic equation, which is x squared plus x minus 12 equal to 0. You either factorize or use bulldozer method to get the values of x. So when I factorize, I'll come up with those two factors, which is negative 3 and positive 4. So in the end, I'll come up with x plus 4 multiplied by x minus 3 equal to 0. Therefore, x is equal to negative 4 or x is equal to 3. But we know that this one cannot be negative. Why? Because if I put this value here, it will become log base 10 of a negative number, which is impossible. Therefore, it is the positive value which is correct. Now we shall go to question 5, which is that solve the following logarithmic equation for y. So that is a given equation, and they want you to solve it. First of all, you should remember that it's the same base, therefore the rules will work. Now what I'm going to do, I'll take this one this side to come up with this line. Then this plus here means that it will be multiplication, as you can see it there. Then eliminate these logarithms because there's no coefficient here and also no coefficient there. When I expand, I'll come up with a quadratic, which will be that, a quadratic in y. So I can either use bulldozer method or factorization to solve. So if I use factorization, I'll come up with, those are the factors, y minus 8 and y minus 12. So that will give me y equal to 8 and y equal to 12 as the values which are required. So now, previously we have not been tampering with the base. So if you are given base 10, you leave it as base 10 throughout. Or if you are given base 3, you leave it as base 3 throughout. But from this case onwards, it will be possible for you to tamper with the base and change it to the base which will work for you. For example, if I'm given this one and it is in base A, I may tamper with it and change it to base C. How do I do that? I'll just come here and look at this one, then put log base C of that one divided by log base C of the old base. So that this identity is very, very vital because you realize that it is used frequently even in UNEB questions, as we shall see. So let's see how it is used. So question 1 says find this without using tables or calculator. So this is what I'm given. I'll first change this one. 27 is the same as 3 to the power 3, and this one is the same as 3 to the power half. Now this is the same base. You add the powers to come up with 7 over 2. Then from here, I'll take this power down to come up with 7 over 2 log base 9 of 3. Now I can change base 9 to base 3 by saying that changing this one to base 3 to become log base 3 of 3 divided by log base 3 of 9, as you can see it here. But 9 is the same as 3 to the power 2. That is why you see here 3 to the power 2. Now this 7 over 2 is maintained. Then this power can also go down here to become 2 log base 3 of 3. And we know that this one and this one cancels, then this over this time divided by 2 gives you 7 over 4. And that is what they wanted. So now we shall go to question 2, which is that show that this log base A of b multiplied by log base b of a is equal to 1. And hence evaluate log base 3 of 8 multiplied by log base 2 of 9. So yeah, start with the left hand side. This one is the same as this. So what I'm going to do, I'm going to put all of them under the same base. So if I choose to put all of them under base A, this one is okay because it's base A, but this one is base B, so I have to change it to base A by saying log base A of A divided by log base A of B. Then you realize that this and this can cancel, so you remain with only this. Then also this one we change, it reduces to 1. So we have shown this. Now let's go to the evaluation part. So this is what is given, and this 8 is the same as 2 to the power 3. That is why you see here 3 log base 3 of 2. And this 9 is 3 to the power 2. That's why you see here 2 log base 2 of 3. So this 3 times 2 will give me 6, as you see it here. Then you multiply by this and multiply by this. Now from there, I realize that this one is somehow similar to this. Therefore, I'll come and equate it to 1 because they told us that it will be equal to 1. And that will be the answer. So now we shall go to question 3, part A, which says that solve the equation this equal to 1. And part B, if A is equal to that, B is equal to that, and C is equal to that, prove that ABC is equal to 1. So let's start with part A. So now here what I'm going to do, this is already base 3, but this is already base 9x. So what I'm going to do, I'm going to change it to base 3. Now this one, the reciprocal, it means if you get the reciprocal, it implies even these ones will interchange. That's why you see here, the whole of this becomes log 1 over log base 3 of 9x. So what was the base becomes the value here. So what I'm going to do, I'm going to take this one this side to come up with that line. Now there's no coefficient here and there's also no coefficient there. So what does that mean? It means that this can cancel, you remain with x squared equal to 9x. Then take everything on one side and factorize to come up with that. That implies that x is equal to 0 or x is equal to 9. But x cannot be equal to 0 because here it was a base, therefore it implies that x is equal to 9. That was part A. Part B, they wanted to show, to prove that if this and that, prove that ABC is equal to 1. So ABC, first of all, this A is that, you're going to come and substitute. So A is that, B is that, and C is that. Now when I convert all to base A, converting this to base A gives you this log base of C divided by log base of B. And this one to base A, the good thing the A is already here, so just get the reciprocal and become 1 over log base A of C. And this one is already in base A, so just leave it as that. Then next is to realize that this cancels with this, and this cancels with this, so you remain with only 1. So basically that is what they wanted. And now we shall go to question 3, which is that given that log base n of m is equal to a and log base x of m is equal to b, show that log base nx of m is equal to ab over a plus b. So yeah, we know that the a is equal to that, implying that if I want to change the base to base m, that this will be now 1 over log base m of n. What does that mean? It implies that this one is equal to the reciprocal of that, which is 1 over a. Then from here, it implies that this will be equal to 1 over log base m of x, to come up with log base m of x is equal to 1 over b. Now I think we realize that now we have same base. So once we have these ones, we can now go and answer our question. So starting from the left hand side, it implies that this one can change base to base m, so it will become the reciprocal, which is 1 over log base m of nx. Now expanding this is the product, that's why you see addition. Then I will come and substitute. So where there was log base m of n, I'll put there 1 over a, and where there is log base m of x, I'll put there 1 over b. So when I get the LCM of this, it will become that. And this division, to make it multiplication, you have to get the reciprocal. And basically that's what they wanted. So now we shall go to question 5, which says that given that log base 3 of x is equal to p and log base 18 of x is equal to q, show that log base 6 of 3 is equal to q over p minus q. So from this one, it implies that 3 to power p is equal to x, as you can see it here, and that will be equation 1. Then also from this, it implies that 18 to power q is equal to x, which is that, and that will be equation 2. Now when I equate the two equations, I come up with 3 to power p being equal to 18 to power q. Put log base 6 on both sides because the equation has log base 6, so put log base 6 on both sides, you come up with that line. Then this power can go this down, and also this power can go down to become this. Now this 18 is the same as 6 times 3. Now when I expand this 6 times 3, it will become log base 6 of 6 plus log base 6 of 3. So when I take this one this side, I will come up with this equal to that. Then from there I realize that this is equal to 1, implying that I remain with 2, and also here log base 6 of 3 is common, so I factorize it outside. And when I make it the subject, I will come up with the required expression. So now we shall go to question 6, which is that show that log base 8 of x is equal to 2 over 3 log base 4 of x. And hence, without using tables or calculator, evaluate log base 8 of 6 correct to 3 decimal places if log base 4 of 3 is equal to 0.7925. So if I first change base, so this one in the reciprocal form, it will become 1 over log base x of 8. Now this 8 is the same as 2 to the power 3, and 3 can go down to become 3 log base x of 2. But remember here they want the ratio of 2 over 3. So what we shall do, we shall multiply up and down by 2. And that will give us 2 over 3, which is here which they want. But now we don't have this. This is base 4, and for us we have base x, so we have to also change the base. So first of all, this 2 will go this side to become log base x of 2 squared, which is 4, as you can see it here. Then from here I can also get the reciprocal so that this one can be interchanged. So when I get the reciprocal, it will become log base 4 of x, and basically that is what they wanted. So now we shall go to the hence part. So by comparison, x will be equal to 6, because if you look at this, this is base 8, and this will be now x, and x will be 6. Therefore, using this proved part, I'll replace it with this. Where there is x, we shall put there 6 now. And that 6 is the same as 2 times 3. And when I expand this, it will become addition here. Therefore, reciprocal of this gives you 1 over log 2 base 2 of 4. And this one will first be maintained, because it is given here in the question. So I'll just come here and substitute it. But this one is not given, so that is why I had to get the reciprocal so that I can change it, because this 4 is the same as 2 to the power 2, and when 2 goes this side, you remain with 2 log base 2 of 2, which in the end will give you a half. So in the end, this one will give me 517 over 600, which is these 3 decimal places. Now remember, they said we don't use a calculator, but to get this we use the calculator, because when they say you don't use a calculator, they want you to use the rules of indices, but at the very end you can use a calculator. So now we shall go to question 7, which is that prove that log base 6 of x is equal to this, and hence given that log base 3 of 2 is equal to that, find without using tables or calculator log base 6 of 4 corrected to 3 significant figures. So changing this to base 3 will give you that, and this 6 is the same as 3 times 2. So expanding this denominator gives you that, so multiplication means that here you put addition. Then this one becomes 1, and that is what was required. Now for the hence part, log base 6 of 4 is equal to this. When you compare, we compare this with this, it implies that where the x is now 4, therefore even here we shall come and put there 4, and also put there 4 alone. Then from here, this 4 is the same as 2 squared, that is why you see here 2 log base 3 of 2, and this one remains. Then we are given the question that log base 3 of 2 is equal to 0.631, so I come and substitute it there. I also come and substitute for this base 3 of 2, which is there. Now at this point, that is when you can use a calculator. So when they said don't use a calculator, it implies they want you to use the rules of indices. So at this point I can use a calculator and round off to 3 significant figures. And now shall go to question 8, which says that given if x squared plus y squared is equal to 7xy, prove that this is equal to that. So that is what was given. Now this one from algebra is the same as x plus y squared minus 2xy. Then when I take this one this side, I'll come up with this line. Therefore make this the subject, x plus y the subject. It means that you put square root on both sides to come up with that line. Therefore put log on both sides. Log this will be equal to log that, and when I simplify, this one can go this side to become a half log 9xy. Then this one can be expanded to become this plus that plus that. So now if you look at this, this is what is required, this is what is required, but this one is not here. So what we are going to do, we are going to bring this half this side to become square root of 9. And square root of 9 is 3. Or you can say that this is 3 squared, and this 2 comes this side to neutralize this half. So in the end we'll be able to come up with this 3, which is here, and basically that is what was required. And now we shall go to question 9, which says that if x is equal to this, y is equal to that, and z is equal to this, prove that x plus y plus z is equal to xyz minus 2. So from here it implies that a to power x is equal to bc, and that is equation 1. Then from here it implies that b to power y is equal to sc, and that is equation 2. Then from here it implies that c to power z is equal to ab, and that is equation 3. Now equation 1 divided by equation 3, this divided by this will give me this. So this is here, and this is here, this is here, and this is there. So this b is common, so it will cancel to remain with c over a. Then when I cross multiply, this goes this side and this comes this side, and same base, so you add the powers, become a to power x plus 1, and here is c to power z plus 1. So when I make a the subject, it implies that this one will go this side by becoming the reciprocal. So that is why you see here z plus 1 over x plus 1. Now when I divide equation 2 by 3, this divide by this, I'll come up with this, and this divide by this, I'll come up with that. So in this case, A is common, so I remain with B over C. And when I cross multiply, I come up with B plus B to power Y plus 1 equal to C to power Z plus 1. Then make B the subject, it will become C to power Z plus 1 over Y plus 1. Now from equation 3, it will imply, we know that C to power Z is equal to AB. Therefore, where there is A, I'll put there this, and where there is B, I'll put there that. So that implies that Z is equal to this, because it was the same base throughout, so it means that you can cancel the bases on both sides to remain with the powers alone. Now here it is plus, because before you cancel the bases, you have to first combine the C to power Z plus 1 over X plus 1 with C to power Z plus 1 over Y plus 1 to give you this addition sign. So get LCM, I'll come up with that. And from here, this plus this is 2, that's why you see 2 there. And expanding this one gives me that. Then when I cross multiply, I'll come up with this line. Now from there, I'll be able to, I'll reduce, and this one is here now. Then XZ is here, and also XZ is here. So that means that they cancel. Then also YZ is here, and also YZ is here, so they cancel. Then now this Z going this side, there was a 2Z here, so 2Z minus Z gives you 1Z, which is here. Then this Y is here, this X is here, and this 2 is there. So next is to rearrange the given expression, and that will be the required proof. So now we shall go to logarithmic equations with unsimilar base. We have been dealing with the ones with similar bases, equations with similar bases, but what if the bases are unsimilar? So question 1 came from UNEB 2015, paper 1, question 3, and says solve for x in this equation. So this is what was given. Next is to change this one. We can get the reciprocal because this A is the required base here. So when we get the reciprocal, it will now become log base A of x, and now all the bases are the same, so you can proceed easily. So because of this addition, it means that these two will be multiplied. When you multiply x by this gives you x squared, and x by this gives you 3x. Then cancel the logs and remain with this equal to that. So that is a quadratic. You have to solve it using either factorization or bulldozer method. Now when I use factorization, I'll come up with these factors, and therefore x will be equal to -4 or x will be equal to 1. But x cannot be equal to -4 because when I put -4 here, log base A of a negative number is impossible. Therefore x will be equal to 1. And now we shall go to question 2, which came from UNEB 2013, paper 1, question 1, and says solve that. So still these bases are not the same. Therefore we have to first look for a way of doing it. So what we shall do, this we shall get the reciprocal of this, which will be now 1 over log base 5 over x. Now from there we shall let y to be equal to log base 5 over x, and come and substitute here and here to come up with this equation. Then multiply through by y to come up with that line, rearrange to get a quadratic equation in y. Then solve it using either factorization or bulldozer method. So when I use bulldozer method, the value of y will be y equal to 1/2. But we know that y is equal to log base 5 of x, so we shall come and replace y with that. And then we shall say that 5 to power 0.5 is equal to x, which is this segment. So when I use the calculator, it will become 2.236. Then question 3 came from UNEB 2012, paper 1, question 15b, and says, solve for x in the equation that. So if I first write the given equation, then this power can go down to become this. And also here you can get the reciprocal because we're interested in getting the same base. So reciprocal will give you log base 4 of x. Therefore, shall let y, just like before, let y be equal to log base 4 of x. Then you shall come and substitute here and here to come up with this. Then multiply through by y and get a quadratic in y. Then use either bulldozer method or factorization method to get the values of y. So y is equal to 2 or y is equal to negative 3 over 2. But you already know that y is equal to log base of x. So for y equal to this, log base of x is equal to 2. Implying that 4 to power 2 is equal to x. And 4 to power 2 is equal to 16. Therefore x is equal to 16. Then for this one, it implies that this is equal to that. Therefore 4 to power negative 1.5 is equal to x. Therefore x will be equal to 4 to power negative 1.5, and when I use the calculator it will become 1 over 8, or you can write 0.125. The now question 4 came from UNEB 2011 paper 1 question 1 and says, solve the equation this. So this is what was given. Next is to make them under the same base. So this is base 5, this is base 25. So I'll change this to base 5 by saying log base 5 of this divided by log base 5 of that, which is this. But 25 is equal to 5 squared, therefore this one becomes 2 log base 5 of 5. And this 2 can also go this side to become 2 log base 5 of 2x. So this one cancels, and also this is 1, so we remain with only this side. Then because there's no coefficient here and no coefficient here, we can cancel out the log to remain with that. Then we shall rearrange to get a quadratic in x, and use either bulldozer method of factorization to get the values of x. But we know that x cannot be negative, therefore x is equal to 1. So now we shall go to question 5, which came from UNEB 2007, paper 1, question 3. And it says, solve the equation that. So that was the given equation. You have to put them under the same base. So that means that you shall get the reciprocal of this, which will give you that. Let y be equal to log base of x, therefore we come and substitute for y, cross multiply third by y, and rearrange to get a quadratic in y. Then use either bulldozer method or factorization to come up with the values of y. Then for y equal to 3, we will come here and replace y with that to come up with that. Therefore 2 to power 3 is equal to x, and 2 to power 3 is 8. What about for y equal to negative 1? So it means that this is equal to negative 1, therefore 2 to power negative 1 is equal to x, and 2 to power negative 1 is 0.5. Question 6 came from UNEB 2003, paper 1, question 5, and says, solve for x in the equation that. So that was the given equation. You change this base to base 2, so it will be log base 2 of this over log base 2 of this. But this 4 is so this 4 can be cross multiplied. Take this one this side to come up with that. And that 4 is the same as 2 squared, so it will give you 2 log base 2 of 2. Then this one cancels, you remain with 2 log base 2 of x. When I take this one up, it will become log base 2 of x squared. So now that there is no quotient here and no quotient here, we can cancel out the logs. So that is a quadratic. Rearrange to get a quadratic in x, and use either bulldozer method or factorization to get the values of x. So but x cannot be negative, therefore a value of x is equal to 2. Question 7 came from UNEB 1997, paper 1, question 9b, Roman 1, and says, solve that. So like we have always done, get the reciprocal of these two so that they are all under the same base. So let x be equal to log base 4 of n. So we'll come and substitute to give you x, multiply that by x, rearrange to get a quadratic in x, and use either bulldozer method or factorization method to get the value of x. So for x equal to 1, to imply that this is equal to 1, therefore 4 to the power 1 is equal to n, and 4 to the power 1 is 4. For x equal to a half, it implies that 4 to the power half is equal to n, and 4 to the power half is equal to plus or minus 2. But n cannot be equal to negative, therefore n is equal to 4 or n is equal to 2. Question 9 came from UNEB 1996, paper 1, question 9a, and says, find x if that is that. So that is a given equation. So you put everything under base 2. So this base 2 gives you that, and this base 2 gives that. So this power goes down to give you this, and also this power goes down to give you this, and also this power goes down to give you that. So this 4 over 2 gives you 2, which is there. And also when I multiply throughout by log base 2 of x, this side will become log base 2 of x. Now 3 minus 2 gives you 1, that is why you see a log base 2 of 2 equal to log base 2 of x. Now when these logs cancel, it implies that x will be equal to 2, and that's what they wanted. Question 9 came from UNEB 1995, paper 1, question 3a, and says, determine the possible values of x in the equation that. So still we shall do the same, follow the same procedure. Convert all to base 2 to come up with that. Let y be equal to log base 2 of x, therefore come and substitute to come up with that. Multiply throughout by y to come up with that, because this is 1, so that is why you see only 6 here. Rearrange to get a quadratic in y, and then use either bulldozer method or factorization to get the values of y. Then for y equal to 2, it implies that log base 2 of x is equal to 2, therefore 2 to the power 2 is equal to x, and 2 to the power 2 is 4. For y equal to 3, log base 2 of x is equal to 3, therefore 2 to the power 3 is equal to x, and 2 to the power 3 is 8. Question 10 came from UNEB 1994, paper 1, question 2a, and says, if this is equal to this, find the value of x. So that is what was given. So we have to convert all to base 2. This is already in base 2, this base 2 gives this, and this base 2 gives that. Now this one is common, log base 2 of x is common in all, so it will be pulled out, remain here to remain with 1, here to remain with that, here to remain with that. Then this one can cancel to remain with only a half, and this one can cancel to remain with only a quarter. Therefore this one, when I add all these ones, I'll come up with 7 over 4, and this one is maintained, this one is also maintained. So when I take this one this side, I'll come up with log base 2 of x equal to 3 over 4. Therefore 2 to the power 3 over 4 is equal to x, and 2 to the power 3 over 4 is equal to 1.6818. So now we shall go to logarithms involving simultaneous equations. So we already covered the topic of simultaneous equations, and it's available on this platform. Just go to the playlist and look for it, and first watch it, then you can be able to understand this topic. So question 1 came from UNEB 1992, paper 1, question 1b, Roman 2, and says, find the values of x and y such that this is that and that is that. So now from this first equation, this is same base, so this addition means that this can be multiplied to give you that, and 1.0 is the same as 1. Therefore 10 to the power 1 is equal to xy. That is why you see here xy is equal to 10, and that is equation 1. Then from this second equation, this is same base and this multiplication subtraction means that you are going to divide. That's why you say division there. Then from there you say that this and this can cancel, remain with x over y equal to 2.5. Cross multiply, you come up with x is equal to 2.5y, and that is equation 2. Now I have two equations and two unknowns, so substituting equation 2 into equation 1 will give you that. Y squared, so divide both sides by 2.5, you get y squared equal to 4. Put square root on both sides, y is equal to plus or minus 2. But y cannot be negative, therefore y is equal to positive 2. From equation 2, from this equation, I can be able to get the value of x, and x will be equal to 5. Question 2 came from UNEB 1990, paper 1, question 1b, and says, express this in terms of this and that, and hence or otherwise solve the simultaneous equations, these ones. So this one is the same as that, and we are going to change this to base 5 to give you that step. Then expanding this, the numerator gives you that, and this 25 is the same as 5 squared. So this one will become, this power can go down to become 2 log base 5 of 5. But this one is the same as, is equal to 1, therefore in the end we shall come up with this. So basically that is what they wanted. So now they want you to solve these two simultaneous equations using this identity or otherwise. So for the hence part, from this one it implies that where there is this, we shall come and put there this. And this one is the same as 9 over 2. Now this one was got from the proof. So multiply, so this and this can cancel, remain with only these numerators. Then for log base 5 of x over log base 5 of y equal to negative 10, we shall cross multiply to come up with this, and that will be equation 2. So substituting equation 2 into equation 1 gives you that. So where there was log base 5 of x here, I'll put there negative 10 log base 5 of y to give you that. So the negative 9 plus 1 gives, sorry, negative 10 plus 1 gives you negative 9, that's why it's negative 9 there. Then divide these 9s can cancel to remain with log base 5 of y equal to negative 1. That negative came from here. Therefore 5 to the power negative 1 is equal to y, and 5 to the power negative 1 is 1 over 5. So now from equation 2, I'll come and substitute for y. So when I do that, I'll come up with that. Then when I take this negative 10 up, I'll come up with this line. So multiple powers, I think you remember that under indices, this times this gives you positive 10. That's why I see positive 10 there. So this can cancel, remain with x equal to 10 to the power 5, and 10 to the power 5 from a calculator is equal to that. So now we shall go to question 3, which is that solve the simultaneous equations, these ones. So from this first one, it implies that x plus y is equal to 10 to the power 1. When there's no base here, it implies base 10. Therefore y is equal to 10 minus x, and that is equation 1. Then from this second one, these two will go up to become log y squared. And because of this subtraction, it becomes division. Therefore this is equal to 10 to the power 0, and then number to the power 0 is 1. Therefore y squared is equal to 30 minus x. Now substituting equation 1 into equation 2, bring this value here, you'll be able to come up with that. Open brackets, you'll come up with that line. Collect like terms to get a quadratic in x. Then solve either by factorization or bulldozer method to get the values of x. X will be 14 or x will be equal to 5. Now from equation 1, after getting the value, when x is equal to 14, y will be equal to -4. When x is equal to 5, y will be equal to +5. And basically that is what they wanted. So now we shall go to question 4, which came from question 4. You say that given that this is equal to that, solve for x and y in these equations. So from this first one, it implies putting log base 10 on both sides. It becomes, this side becomes x log 3, and this side becomes 3y plus 1 log 2. So when I take this one this side and this one this side, I'll come up with this expression. But the good thing, I already know that this is equal to 8 over 5, so I'll come and put it there. So when when this one goes this side and this one comes this side, I'll come up with this line. Rearrange, you'll be able to come up with the equation 1. Then from this second equation, put log on both sides, you'll come up with that line. Then bring this one this side and this one the other side, you come up with that. So 12 is the same as 3 times 4, so 3 is that, and 4 is the same as 2 squared. 4 is the same as 2 squared also here. Therefore, when I expand this, split the numerator, this will be log 3 plus 2 log 2. So when I split the numerator, it will become log 3 over this plus 2 log 2 over this, which is that. So this one becomes 1, which is there, and this one, there's this 2, which is maintained, but then this remaining one is 8 over 5, which is this. So when I add these two, I'll be able to come up with 9 over 5. So 9 over 5, it means that when I cross multiply, I'll come up with, remember here it was this, now is equal to 9 over 5. Therefore, when I cross multiply, this will be multiplied by this to come up with this, and this will be multiplied by this to come up with that. Open brackets and make x the subject to come up with equation 2. So we have 2 equations and 2 unknowns, so next is to solve them simultaneously. So when I equate the 2 equations, I'll come up with that line. Cross multiply, open brackets, make y the subject, y will be equal to 9 over 23. Then from equation 2, x will be equal to that, substitute for y, and be able to come up with the value of x as that. So that brings us to the end of this video. Thanks for watching, and be reminded that the next video will be on quadratics and polynomials. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on quadratics and polynomials has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.